name is Shaun McQuaid. I'm with Mercury Systems. I'm responsible from a product management perspective for the processing product line there. And so the talk today is going to be a little bit about how do we take the buzzword of days past, right, cloud computing, and talk about putting that into tactical systems. It's an interesting topic to talk about because, again, I think you can see from some of the conversation that's happened already today that the cloud is kind of something that may not be at the forefront of everyone's thought process these days. It was kind of a buzzword of maybe a year or two ago, but that doesn't necessarily mean that it's not something that we can leverage and take advantage of. But basically what that means is it's gotten to a point where there's some maturity involved. And a lot of what this talk is about is saying, how do we take the technologies, the capabilities, some of the work that's been done in the commercial industry as far as cloud computing is concerned, and leverage it into today's platforms? And then also, why would we care? Why is that something that would make sense for our industry to do? And so I thought it would be good to start out with just an anatomy of the cloud from a admittedly less than expert perspective. So I hope that you'll bear with me. But when I look at the cloud, I think of folks like Amazon, like Google, like Microsoft, who are building out their own kind of cloud infrastructures and really offering processing as a service, storage as a service, infrastructure as a service, software as a service. This is the kind of ecosystem that's out there today. If you happen to be in the world of commercial computing and you have work to do, you're looking at basically renting out flops for pennies an hour, or storage, or terabytes at dollars an hour, whatever the going rate happens to be. And how is that really beneficial, and how can you leverage that into today's industry, into the kind of embedded form factors and systems that we're all interested in today? You really have to understand the anatomy of what's going on there, and this is a kind of representative picture. But if you look at what's going on here, you've got a set of rack mount servers all stacked up, miles and miles of these things, all wending around, a highly thermally managed environment. So there's a lot of work out there to say, how do I provide power to these data centers? How do I make sure that from a cooling perspective, they're all in the right kind of air-conditioned temperature range, things like that. And at the end of the day, you're looking at how the cloud has really created a whole suite of market spaces and market niches for OEMs, for chip vendors, folks of that nature, to actually invest in. You can look at Intel's kind of processing roadmap and see how this has skewed it, because you look at the laptop market, the Core i5, Core i7 processor family, that's been continuing for a while, but their focus is really, when they innovate on the processor side, has been on basically delivering the same kind of performance down and lowering the power draw so your battery life lasts longer in your laptop and things of that nature. You don't see the processors growing in core count. You don't see a lot of advances in anything other than perhaps the graphics capabilities of this side of the world. When you look at the server class line, what's kind of servers that end up in this kind of an architecture, what they're really focused on is maintaining that power curve, right? So they say, I've got a maximum number. I've got these servers set up. I don't want to necessarily stress the infrastructure that I'm going into, but I want to deliver more capability, more performance. And so the server class line, which Intel refers to as their Xeon class, continues to advance. And it actually continues to bifurcate a little bit too. You start to see some of the microserver market take off. There's some new developments in that space coming forward. The general big metal server class processors continue to make their presence felt. And then, of course, at the end of the day, as far as the cloud is concerned, you've got to deal with the I/O into the cloud. If you've got a whole suite, hundreds, thousands, millions of users who are trying to access this processing technology, you've got to have a good, solid infrastructure in place to get at that and to provide them the access that they need. So you're looking at high-speed networking capabilities going from gigabit Ethernet to 10 gigabit Ethernet to 40 gigabit Ethernet to 100 gigabit Ethernet, whatever the case happens to be. And a lot of what I've seen has been the evolution of that and how quickly they have to turn these cloud infrastructures. You can imagine when you have data centers that are full up of these thousands of machines, hundreds of racks, going in and swapping out the NIC card in each and every one of them on a yearly basis is probably not a good use of your funds or good use of your time. You really need to look and say, is there a better way? There's a couple of interesting articles out there that are proposing some different techniques around that space, particularly in the use of FPGAs to change the technology up, to change the protocol that's coming in, maybe enhance the speeds without having to swap the NIC out. Microsoft actually put out an article about that recently that I thought was pretty interesting. So this kind of, again, the anatomy of what a cloud is today in the world that's out there. And it kind of harkens back to some of the old days of where you have a client infrastructure and then a mainframe out in the distance who's actually doing the work. So contrast that with today's tactical embedded model, where you have a very linear kind of progression going from data coming in from a sensor digitizes that data, it gets sent off to a sensor processing system of some kind. The work that's done there kind of takes that data, extracts some actionable information, sends that forward off to a mission processor who's deciding what to do with it, whether to take some independent action or whether to display data to an operator, whatever the case may be. It's a very linear path, right? And that's kind of the waterfall model that has come out of the past, kind of pre-cloud. This is something that it makes a lot of sense for the industry that we're talking about because this has been the case for 20, 30 years at this point when you look at a tactical platform. Kind of a big jump from this world over to something that's a little more cloud-based. And that's kind of why I think there hasn't been a lot of movement in this area to date. If we think of the future, right, there's ways where you can actually, in the industry today that we're existing in, the pieces and components that make up a cloud infrastructure are already becoming in place. We have lots of capability out there as far as processing is concerned. We are in our 4th generation at this point of utilizing the Xeon class processor. Additional processors are coming to bear that can easily be leveraged into this infrastructure and be treated as server class. On the I/O side, there's a significant amount of advancements lately in high-speed interconnects. There's been a lot of work done to get the bit error rate down to basically prove that over the wide environmental range that we need to exist in our industry, that we can actually get the speeds up. A lot of folks have invested in backplane work, in connector work, to get up to these 10 gigabit, 40 gigabit speeds. And then at the other side of the coin, storage is becoming a big deal as well. And a lot of folks out there, you can look at our industry and see storage is something that many people have invested in these days, and particularly rugged storage, where there's the ability to take these kind of SSD-type technologies and deploy them in a way that can actually be survivable across the shock, vibe, temperature, humidity, EMI kind of spectrum that we all kind of know and love at this point. So the ingredients are there from a hardware perspective, but what about the software? So at the end of the day, what you're looking at from a cloud software perspective is the ability to have kind of the flops on demand model from a software perspective. As these pieces come together, what you really want to be able to do is deploy the software in such a way so that if you have a publish-subscribe model, whereas a client comes online that requires a particular task to be completed, it says, I need some access to processing, I need some access to memory, I need some access to storage, I have an I/O requirement, and having the server class out there, the server, provide that's from a software perspective, that's something that's developing, and all the ingredients that make up that kind of an architecture are, again, becoming state-of-the-art as far as our industry is concerned. For folks out there who are deploying with the world of Intel, there's a whole lot more focus on Linux being out there. Standards-based software implementations are really becoming the norm at this point. You're looking at a lot of socket-based communication, a lot of open software, OFED stack, the open MPI layer, a lot of different pieces that coming together that actually are very open and allow us to actually do the deployments that you want to see in this area without necessarily having to do things from scratch or leverage legacy models. Now, the other side of the coin is virtualization. Because at the end of the day, if you can't emulate some of the older systems of the past, then you have a massive code porting exercise that you have to go through. And so a lot of what's necessary for virtualization comes at the BIOS level, making sure that your BIOS is aware of hypervisors, making sure that you're capable of deploying modern technology as far as that is concerned, the use of virtual machines. And again, this gets back to the requirement to have a set of server class resources available so that you can create these virtual machines, create these virtual environments on the fly as you need them, and again, look at leveraging capability. Finally, I want to point out high availability is a key here because the last thing that you want to do is get a busy signal if you're a client asking for processing resources. So a high availability component. And again, there's a lot of work out there that's been done to take the kind of work that the cloud infrastructure providers have done, bring that into the open side of the world, and leverage that into these kind of ecosystems. I think that we have all the ingredients that are necessary at this point to bring this kind of an ecosystem into a tactical platform. Imagine where you have your UAV or your highly capable platform out there. There's lots of different examples you could look at. Where you have a base server architecture that's providing the horsepower for any number of different applications. And then each of the mission processor or each of the different sensor processors are really thin clients in some sense that are requesting resources, taking advantage of what's possible out there from the server, and bringing that forward to the platform. I think the advantages here are pretty extreme because at the end of the day, what you're really trying to do at this point is take advantage of what the commercial industry is bringing to bear. If you look at some of the better buying power memos that have come out of DoD lately, it's all about being able to take advantage of what the commercial industry is doing and deploy that into tactical systems. In this case, what we're really looking at is how can we leverage all this investment that's been done, both with all the chip manufacturers, all the OEMs, and bring that forward into a place where there's some leverage there. The other side of this is upgrades. A lot of spiral upgrades are in place in our industry right now. In my experience, upgrades to existing platforms far outweigh new starts in our industry. And so you want to look at upgrades in general and say, how can I make that a more cost-effective endeavor for the programs that are going down this path? The way that I see this working is, again, if you have one big server complex that's taking advantage of the Moore's Law updates that happen to the processor roadmap, kind of riding the wave as Intel, the storage vendors, the folks that are out there kind of advance their technology, then we end up in a situation where it's a lot more easy to upgrade just that one server complex than it is to upgrade multitudes of boxes all the way across the platform. And then from a client side, as you get new capabilities that you'd like to deploy, it's easier to deploy a thin client that's actually just providing an interface and some front-end processing to request from a cloud-based server, kind of a tactical cloud on your platform, than it is to build an entirely new processing ecosystem from scratch. And so I think that's kind of the value proposition for this kind of an architecture. And I think that if you look around the room, the folks in this room have contributed to bringing all these pieces of infrastructure to bear, whether they be hardware, software, virtualization, whatever the capability may be. I think we're here. And I think that it's really just a matter at this point of building up some potential use cases, demonstrating some capability here, and actually showing some of the actual advantages from a financial perspective, from a schedule risk, time to market perspective. So again, from someone who's not necessarily the most informed in the cloud computing world, but it seems to me like we have all the pieces that we can bring to bear in this space. And I'm hoping that that can resonate with some of the folks that are out there today.